Good morning to all. Uh, Today I am going to the topic a case study on piecewise regression using cubic spline in the agriculture department students third year fifth semester in numerical method subject. First, regression reveals spatio-temporal variability and determines sediment yield, which is a key to appropriate watershed management. Considering several curve numbers as nodal point in the domain. In this case study, we have constructed the approximate curve using cubic spline corresponding to the sediment yield also. It is observed the cubic spline show the satisfactory performance with loss efficiencies to 61.36%. We have established the quality of approximation by comparing the given value with the approximate value of SYI at certain nodal point and noted that these values are quiet, and hence it is concluded that the approximation is satisfactory and may be quite useful in the field of applications. Next, going to the introduction. The soil erosion may be defined as the detached and transportation of soil. Water is the major agent responsible for this erosion. In many locations, winds, glaciers, etc. also cause soil erosion. The watershed planning and management highlights the management techniques to control erosion in the catchment watershed area. Due to lack of data availability, estimates are made by means of prediction models that evaluate soil loss or sediment yield separately. Alceles proposed an empirical relationship between SYI and area and delivery ratio. A different approach proposed an empirical relationship between delivery ratio and morphological characteristics of catchment such as catchment area, average relief or slope. These models are popularly employed because of their simplicity and easily available data. Next, it is the common experience that the sediment yield largely depends on the rainfall generated runoff, which in turn relies on the parameter curve number of soil conservation service curve number methodology. The larger the CN value, the larger will be sediment yield in agriculture, watersheds, and vice versa. Since CN represents the runoff producing potential of watershed and SYI, the potential of sediment yield, it is quite logical and these two parameters, viz SYI and CN, should exhibit some relationship between them. And multitude the studies have applied cubic spline at regional levels. If the spline applications and increasing day by day in the field of medicine, agriculture, engineering, and other sciences, they are limited in soil erosion modeling. Therefore, the objective of this paper is to apply cubic splines in erosion modeling as they have proved to be the best approximation. They are used to obtain the value of approximate curve number corresponding to an arbitrary sediment yield index. Next, study area and data sources. Narmada is the largest west flowing river of the Indian Peninsula. It is one of the important rivers of India. The Narmada River rises the Amarkantak Plateau of Maikala range in the Sagatur district, Madhya Pradesh, in evaluation of 1057 meters above mean sea level at a latitude 2020 2 lakhs and 2040 and longitude 8,001 lakh 45 81,045. Bamhini watershed 2,542 kilometers square. Manat watershed 4,884 kilometers square. Makhan watershed 3,978 kilometers square in Mantala district, Madhya Pradesh, India. The three adjacent watersheds, namely Bamhini, Manat, and Mahakian, conjoin together to form an important southern sub-basin designated as combined watershed. Next, land use and land covers. Meaning, graphically mapped the was used to the watershed delineation. The landshed satellite data downloaded in the global land cover facilities. Maryland websites were used to prepare the land and land cover map. The supervised classification has been used in this study for classification of satellite data. The land use cover classes were agricultural land, follow barren, open land, water body and forest. Areas occupied by each land use were determined. Narmada watersheds have a good forest cover and agricultural and barren land. Maximum 65.45% area is covered with agriculture in Manut watershed and 59.03% forest in Bamhani watersheds. Next, going to the soil map. The soil map of the study area is generated with the aid of NPSSULP map. The area is under different soils were identified and are the presented in the above diagrams also. After analysis, it was found that the area of all watersheds fall under the hydrological soil group B, loamy soil, and hydrological soil group D, clay soil. To create the CN map, the high hydrologic soil group and land use map were uploaded to the ArcView platform. The hydrologic soil group field from the soil theme and the land use field from the land use map were selected for intersections. The weighted CN values for the study watersheds were computed using formula sets land used and the soil maps also. The soil map study area is generated with the aid of NPSSLs. They create CN maps also. The hydrological soil group field from the soil theme and the land useful field from the land use map were selected in the intersections also. Where the IA is the initial abstraction, F is the cumulative retention, lambda is the initial abstractions ratio, S is the maximum retention capacity, P is the rainfall, Q is the direct runoff. For convenience in practical applications, S is the defined in terms of dimensionless parameter Cn, which varies in a more restricted range also. Soil maps is one of the areas is called this one. Next, going to the slope map. The digital elevation models were generated from the SRTM data. From these maps, slope maps for the Narmada watersheds that were generated, and investigation of reveals that about 95.1% Bhamini, 96.88% Manut, 96.99% Mahakyan of the catchment area of the watershed fall under two slope categories, gently and moderately sloping. That is the slope map areas also given. Next, going to the conclusion. A cube spline is developed between SYA and CN using 11 subwatershed data. This approximation is validated for sediment yield index for the remaining subwatersheds. Subsequently, the SYA observed data of combined watershed exhibit a strong correlation with SY derived using the cubic spline. High R2 values support the general applicability of the proposed concept has been noticed and established theoretically that the cubic spline are best approximates for most of the practical purposes. In this case study, the authors have verified that after computing the cubic approximation at some particular nodal points, the actual values of SYA are very close to the approximations values. The particular nodal points, the actual values SYA are very close to the approximation values. Hence, we conclude that the approximation is acceptable. And the major advantage of this construction lies in getting an appropriate value of SYA at every arbitrary nodal point of the domain of curve numbers. In case when there is a more fluctuation in the data points, then we may not be able to compute appropriate cubic spline approximation. Thank you. Thank you for watching my case study.